All right, for the second part of our 3.6 day one notes, we're just going to talk about a couple other kinds of problems. Next one is working the problem in reverse. We know we'd love to have you guys think about problems as working them backwards or undoing the thought process. It's harder to do, but it's definitely really good for your brain just to be able to analyze and unpack stuff and see if you can make it work. So what we're going to do is give you all the components of a rational function, like the graphing components, and see if you can build that function up and see what it's going to be. So in other words, our ultimate goal here is what's the rational function that has this as its pieces of the puzzle. So where do you start? I always think there's kind of an easy order to this that makes sense to me. The first one I know that I'm going to do that's kind of clear cut is the VAs, because those had to come from factors in the denominator, the numbers that cause division by 0. So I feel like that'll always be a fairly simple starting point. So I'm going to change these into factors. And then also I kind of like to do a dual thing here where I'll work on a factored version, which helps me see some of the pieces of the puzzle, and I'll also work on a multiplied out version, which is the end result. And between both of these two, I'll eventually get there. So that's a good starting point. As far as some of the other stuff goes, I'll go to my x-intercept next. The x-intercept would have come from the numerator. Now, here's the thing. With an EBA, we got to sort of back up for a second. With an EBA of 3, in other words, not 0, so anything but 0, essentially, that means my numerator also has to be x squared, because the only way I'm getting 3, and I already know this is a 1 sitting here, is that this term has got to be 3x squared. If that's the case, then one of my factors over here has to have a 3x in it. In other words, 3x times x is 3x squared over x squared produces this. Now I'll kind of cycle back around to all that in a minute. What that really means then is my x-intercept here is really one of two x-intercepts, because I would have two factors in the numerator also, because it's squared on top as well. So how I'm getting to the idea of knowing this is also quadratic is that this is, the EBA is 3, and I would have to have the same degree top and bottom to pull that off. So that means that's one of my factors. Turning my 0 into a factor. Okay, well now let's tie it back into the idea of EBA. So I know that my EBA has got to be 3x squared. Again, we already kind of mentioned that. I could have popped that up probably first before I even did this. So we're definitely going to tie these two ideas together. But that means I've got 3 over 1, lead coefficient over lead coefficient. And again, I knew because of the kind of EBA I had that my numerator was also quadratic, which helped me realize that this was one of two factors, one of two x-intercepts. Okay, but then what is the other one? Well, now we're going to shuffle down to y-intercept. The fact that this has been multiplied out and I know what my last term is, I also know that a y-intercept is produced by plugging in 0 for all of your x's, which means I need to figure out what this number would be when divided by negative 12 that would produce 1/6. Well, that's not a whole lot of reasoning there then. Once I get it, that's going to be negative 2. So negative 2 over negative 12, positive 1/6. That also would have to be the other factor, because when I multiply, FOIL it out, these two have to produce negative 2. Well, really, all I'm left to do now is FOIL the numerator over here and get my middle term. So negative 6 on the outside, positive 1 on the inside for a negative 5. And there's my rational function that has that information. So as you first read through it, you might go, well, you know, there was no way I knew about a second intercept. And you didn't know about that when you started. But as you start to build it up and reason it out, eventually you get there. Okay. The last thing we're going to do is look at a quick word problem. And so the idea here is we're going to start with a rational function. I'll kind of talk you guys through it. I've kind of got a little bit of graphing going already. And then we'll go to our calculator and we'll kind of walk our way through the whole thing. So the idea here is that if you had surgery, you're going to get an injection of a pain reliever. So you've probably got an IV in and they're going to give you some kind of pain medication. And if you think about how this would work, when you get an injection into your bloodstream, if you guys have ever had a surgery, you've got an IV and whatever they give you is going to go in there quickly. Different than you taking like an Advil for a headache, where you've got to digest it, it's got to get into your bloodstream. You don't get immediate relief. You get relief, but you know it's not like instantaneous. Pretty much you get an injection and it gets in your bloodstream and moves throughout your body and you're feeling your relief really, really quick, which is of course the idea. When you're in severe pain, you want that relief right away. So you would assume in this scenario that what's the graph look like? A spike. So a quick burst, you know, that gets in there, the pain relief skyrockets, you're at maximum relief, and then if you don't get another injection, of course your body's going to use the drug up, which is no different than any other, like a pain medication, like an Advil, for example. So you use it up, you use it up, you use it up, If you're still in pain, guess what? You get another injection, you take another Advil. But if you don't get another dose, it will start to drop. So these are some points that are kind of plotted on the way to sort of point that out to us, and I'll come back to that in a second. But a quick spike, in other words, it's in my bloodstream, I'm getting full pain relief, so maximum amount, milligrams per liter, excuse me. And then I don't really get another injection, so pain. Now, there's a point at which I'm probably going to say I need another injection, and we'll discuss that too in a minute. Let's go over the calculator for a minute and put it in, just talk about some design here. So I've already got into my calculator. I'm thinking about window. The idea here is if I got a, a paper window given to me, then I would just model my paper window. So we're time in minutes, I've got it out to about a half hour, and then we're concentration bloodstream, I've got it up to 15 milligrams per liter. So what I want to do is make my window match, which is what I did here. Now I went out a little bit further, I went out to 40, but 0 to 40 scaling by 2. 0 to 15 scaling by 1. Again, if you were working this in reverse and we asked you guys to transfer graph from calculator to paper, this is what you'd have to show me on the axis, going the other direction. But the fact that I've got it sitting here for you guys, then we're good to go. So get it into your calculator, get your window set up, and then go ahead and hit graph, and let's see what we got going on. Now, what I see is exactly what I expected, right? I've got this real quick increase in the dose in my bloodstream. In other words, I just got the injection, the pain relief, the level of the drug in my system is on its way up. So while I have the maximum amount of drug, I also have the maximum amount of pain relief. And then as my body starts to use up the drug, so less and less of it's in my system, and then the pain starts to increase. So one of the questions would revolve around max. At what time how long did it take till I reached the max, till I got that full dose in my bloodstream? So, we know how to use this stuff on our calculator. Let's go do the max quick, number 4, and check it out. This will also prove the point that the fact that it's an injection, that it happened really, really quick. So remember, we're doing our left and right marking system when we do a max. Let me get over there, show you what's going on. And don't forget to hit guess. So literally 1.4 minutes. So I got into my bloodstream, it circulated, my heart pumped a few times, it circulated, and all of a sudden I've got it in my bloodstream and I'm feeling relief. The dose, the volume of it in my bloodstream, 10 milligrams per liter. Okay, so that's pretty quick and easy. We got that part figured out. Then there's some questions about interpreting the graph and what else can happen in the problem. So I'm going to kind of just go ahead and pop up what we just saw. You can see how that curve matches those points that I had, so we got that idea. And those points, by the way, that's just me plugging into a function, just picking some values along the way. Let's fade that one out of there too. So there's what we're looking at. Now, the last part of this question is actually saying, well, two things, I guess. I kind of threw in an extra question, the max, but what eventually happens to the concentration over time? Well, you know what, it's going to approach 0. And if you think about it, this has got an EBA of y equals 0, or in this case, the milligrams per liter equals 0, because eventually I'll use it up. There'll be nothing left in my bloodstream. How long does it take from the initial injection after the max concentration is reached for your concentration to drop below 3 milligrams per liter? Now, the idea here is probably there's a point at which I'm back in pain, and the nurse is going to probably come in and actually talk to me about it every so often and say, all right, what's your pain level? And you're like, well, not too bad. And then a little bit later, I'm starting to feel pain. A little bit later, I'm feeling pretty good pain right now. I could use another dose. And then the nurse would be taking down some notes about time. And then they would basically adjust the pain medication and probably get it on a drip or something where you get a periodic dose, keep you comfortable for a while. So let's go to the calculator and analyze that a little bit. As far as when the milligrams per liter drops below 3, well, then I need a y equals, because that's milligrams per liter. I need one at 3. So in other words, I'm going to shoot a line through my graph and check it out. What I'm most concerned about is right here, not here. Here, the volume is on the way up, so relief is on the way up. Here, relief is on the way down. And this may be the point at which I can't really take it anymore. I need another injection, so that may be the time frame when the nurse goes from, we'll let like 10 minutes, 20 minutes, whatever pass, then we'll give you another injection. Okay, but we need to figure out what that is. This is called intersection. We haven't done much of this yet. It's still in the menu that we like to use where all of our features are, the calc menu. And it works pretty much the same. In an 84, all you got to do is get your cursor right on basically top of the spot. In an 89, you got to do a couple things. You got to choose first curve, second curve. You got to mark left and right, and then it gives you the answer. In an 84, you basically just have to choose your curves. So it's like first curve, check, second curve, enter, check it out, guess. And as long as I'm sitting there, it'll tell me what's going on. So essentially about 10 minutes when I reach that 3 milligrams per liter. And that may be the way the nurse takes care of me. Okay, so about every 10 minutes we give you another dose, at least for a while. Okay, and so then that produces that graph. So my answer to this question would be basically about 9.8 minutes. Okay, it's always good to do a little visual interpretation and also think about the context of a problem and also have an expectation of what you think you might see so you're not going to the problem blindly, just sort of randomly hoping you see what you want to see. And that's going to do it.